Again, I'd like to congratulate everybody who's here in the room for having found the place. I think we're getting better at that. I only got lost twice. So let's give ourselves a big hand of applause for finding here. Okay, my name is Wayne Gramlich, and I'm the president of the HomeBrew Robotics Club. And tonight we're going to do some administrivia kind of stuff. Last November, we voted in the bylaws for the club and set up the executive committee. And we've been waiting for a piece of paper from the California Secretary of State that basically says we are an official California unincorporated association. And we are. Bill, could you hold up the little piece of paper? There it is. $25 of fee and two and a half months of processing. But what can we say? We'll be able to go to a bank tomorrow and open up an account with the bank. Okay. Yeah. Okay. So what we're going to do is we have to do some votes tonight. Now the votes are going to take place after show and tell. Then that's so that everybody has time to get an envelope, which I foolishly did not bring up here, and put your dues in there. You can pay by check or by cash. If it's check, you make it to HomeBrew Robotics Club. If it's cash, it's just $10. And you write your name, and we're trying to collect two pieces of contact information: a phone number and an email address. We're not likely to use these at all, but just in case we need to contact you, we would like to be able to have this stuff on our internal file. And then if you're a family, you would want to put down your family member names, okay, and they'll have memberships as well. I will be modifying the badge software to use the spreadsheet that all this information is being added into, and that will start generating the badges. So next meeting, hopefully everybody who's signed up this meeting will have a badge, and then that's how we'll be keeping the badges going from here on out. Does anybody have any questions on the membership stuff? This is good. Could somebody just sort of pass out the envelopes so everybody has envelopes? Could somebody? Thank you. Yes. Okay. I think he can read your address. The envelopes are really for the people who need to stuff $10 in. I didn't bring my checkbook tonight. Oh. I actually, one of our members from Southern California, Walt Perko, wanted his name badge to be slightly different from his name. So you can specify a slightly different name. Let's keep it family friendly, though. Okay. So I'll go through what the votes are so that right after the show and tell, we can just go through those really quickly. The first vote is actually done by the executive committee, and it's to vote everybody who's signing up now into the club. It turns out the club only has 5 members right now, and that's the executive committee. And that's because you folks voted us in last November. Now we're going to vote you folks into the club. And yes, there is method to this madness. It turns out we have to control our membership, and so that's the voting is how we do that. After that, we do the budget vote. The budget for the upcoming year is $800. $500 of that is to set up the bank account. About $100 of that is to pay for badge and badge materials. And approximately another $100 of that is to pay for our website. And I'm spacing out what the last $100 was for. So that'll just go into the bank account until I remember what it is. Okay. The next vote is the vote on what the memberships are going to be, and we sort of talked about it last time. We're doing a family membership, $10. Oh, sorry. The membership is per family, one person. So if you aren't a family, boy, I'm really mingling this. Okay, one person constitutes a family. So, but if you have other, spouse or children, you get in on that membership as well. Okay, and the third vote after that is to agree to the dues for the year as being $10. Okay, so those are the three votes that we get to do, and then we can get to go on to the more interesting thing, which is the talk. Okay, so having mangled all of that, does anybody have any questions? No. Okay. So good. We get to go to the show and tell portion of the. No, hang on. We wanted to let the people who are doing the event presence give a little talk. So, Ralph, you wanted to say something about National Robotics Week? Is wow.
Okay, a lot of you probably saw the email I sent out last week about the events that we're kind of trying to plan for National Robotics Week this year. Last year we participated in the robot block party, and we're going to try to do that again this year. Although it'll be at a slightly different venue this year at the Vale building. I guess it's the Volkswagen Advanced Automotive Research Lab or something that they have over there. It's a new facility. It's still at Stanford. The timing is a little bit vague right now. That one part of their website said 11 till 5, and another one says 2 till 8 p.m. And when I questioned it, it seemed that 2 to 8 p.m. tended to be what they were thinking of, but I'll have to confirm that on the website. So what we are looking for is commitments. Who wants to show up at the Robot Block Party? It's April 14th, so it's either going to be all day or it's going to be more of an afternoon into the evening event. We'll confirm that, but next week, there's actually having a meeting at the building and getting everybody who wants to present to be there. So I don't know if I can make it, but if I can't, I'll try to solicit somebody from here who can go and represent us and sort of fight for some space that we can use. So having an idea of how many people would like to come would be good, so we kind of know how much space we really should be asking for. I'm not sure that it's as good a venue to have the outside. Last year we kind of had the outdoor perimeter, and that worked out really well on the balcony, but I'm not sure there's such a good space at this new building, so we want to probably try to fight and get an inside area. But anybody here? I know Tony, you responded and said you guys are bringing your robots. Anybody else who's thinking you're bringing a robot to the robot block party?
It was a lot of fun.
Yeah. So, okay, so we've got enough interest there that if I can get 10 by 10 or something space, hopefully something a little bigger than that, but I'd say that'd be kind of the minimum. 10 by 20, I don't, we'll find out next week. And if you are going to, sorry? April 14th, it's a Thursday. So, it's late in the week. I mean, the National Robotics Week runs from the 9th, to Saturday the 9th, through to the following. It's at the 14th, 15th, I guess, is the last day. And then the 15th, 16th, 17th is Robo Games, which they kind of tack on as part of National Robots Week now as well. So see Dave at the back there, he can tell you all about that. And is it Ken? The guy that's Kent Williams. So,
is he here tonight?
No,
he's our Robo Games liaison. I was hoping he'd be here so he could meet
Dave. But anyway,
Kent,
there is somebody called Kent Williams who's representing the club for Robo Games. So if you know anything about that, do that. The other event that I did want to encourage people to get involved in too for National Robot Week is, what about a HBRC open day? I mean, they say, let's have clubs, let's have an open day. If you've got a club, have an open day, get the public in. I've been talking to Dave. We're going to probably try to talk to Tech Shop because they host our SIGs, and it'll be a great space. We can kind of tie an event in a do-it-yourself robot day. So people can come. If we've got our robots there to show the people, Tech Shop can sort of jump in and have tours of their facility, and you can sort of give the public a whole view of, this is how you can build your own home robot. So anybody interested in doing that, I'd probably suggest, as soon as we have the robot block party on the Thursday, maybe we'll look at doing that earlier in the week. Saturday even would be probably a great day if people wanted to do it on Saturday the 9th. That's one of the days within the robot or the National Robotics Week that they're really looking for events. So again, show of hands, anybody who'd want to come along and show off robots at an open day, open house sort of thing. So it sounds like it's worth following up on that too, and we'll get some details on that. So the other details will be, they're looking for presenters who want to do talks, and they're talking about panel discussions and things. So if you have a perspective on the robotics industry and you want to get up there and have 5 minutes on the soapbox, they're looking for people to volunteer but I think mainly during the robot block party sessions, they'll have a corner away and they want to have some speakers get up and talk about things. So anybody interested in volunteering, got some time that I want to do for that, again, drop an email to me. I want to see that. And I think, Wayne, you volunteered to do a thing on the club. So if we can present a couple of people who want to do talks, they'd love that too. And of course, anybody who just wants to volunteer some labor time to go and help them set things up and pull it down, they're interested in that as well. So we'll work together on finding out more about that as we go forward. So the website was on the email if you want to find out about it. As far as committing and trying to get the open day done, the press releases officially go out next week. So if we can get all the details confirmed, we'll actually get into their official press release if we can get the details and register the event by next week and give them the details. So
we just have to, let's do tech shop, let's coordinate with
Jim and those guys.
With Jim and those folks.
And we'll try
so
to
that they can do something.
They can get their name out of it.
Just one comment, Rob. When you meet with the Stanford folks, it would be good to just kind of scope out what's useful for parking, because that's always an issue whenever you go to the Stanford campus.
That's been discussed, that there will be no free parking at Stanford. They say that about 3 minutes away there is a parking lot. Now, I guess
3 minutes while carrying.
Walking, yeah. So I don't know whether it looks like from a photo on the website of the building, there's a parking lot right in front of it, but it's not. But they'll probably allow people to be able to pull up there and drop stuff off. Now, they were talking, people from Stanford were talking to the people. There's a conference call every week now that I've been attending to sort of where they're discussing that, and the question of parking came up. And there is an opportunity for either us individually or as the whole robot block party group to negotiate with Stanford, and they have like event parking permits you can buy ahead of time and stuff. So maybe if we think it's worth it, we can either book parking spaces if we know how many we want. Or they say, you just pay on the day and put money in the voucher and walk 3 minutes away. They say there's parking. So that is something that's been negotiated. I'll have updates on that in the next few weeks as well as we go forward. Okay, that's it for me for now.
Dave, do you want to come up here and make a pitch? Let me introduce Dave Calkins, who's been running Robo Games for us for so long. And thank you so much.
Thank you. So as far as RoboGame, I'm taking notes because that way I remember to tell everybody. Several announcements. One is due to the generosity of Ryan and Google, they're offering $5,000 in prize money for this year's RoboGames across 2 competitions. So not all 70 competitions, but just 2. The first one is Best of Show for those of you who here has not been to RoboGames before. So I know how many. Okay. So it's based on an Olympic model. So instead of just doing a Lego event or just doing sumo or whatever, there's 70 different events, wide-ranging across the board. One of those events we started in the second year, which is called Best of Show, which is we saw people who would make cool robots, but it wasn't a sumo robot or it wasn't a combat robot or it wasn't an android. And we're like, we need to put that Best of Show robot, we need to put these robots in some category. So we just call that Best of Show, which is just make up a robot that is cool. And it can be anything. I mean, I think Camp won one year for springy thingy. Silver.
One of the highlights of my life.
You know, I mean, Best of Show robots have been just across the board. It's been that. It's been a robot that played Connect 4. And so it'd play Connect 4 against a human. And I think it beat all but like 3 humans over the course of that particular weekend. So $2,500 of the $5,000 prize money is dedicated to Best of Show. So for all of you who have any kind of robot that you want, it's $2,500 broken up 60, 30, 10. So it's $1,500 for first place. What is that? $450 for second, and $750 for second, and $250 for third. That same prize package is also across a new competition in the sumo category, which is an attempt to sort of push start more cloud robotics stuff. So one of the competitions, one of the founding competitions of RoboGames was sumo robots. And while we have many different weight classes, the 3 kilogram is really the hefty class, and I actually brought one. So for those of you who've never seen a 3 kilogram sumo, they look like this. So traditionally at RoboGames, 3 kilogram has been broken up into 2 classes, which is autonomous, that is you program some kind of microcontroller to independently push the other robot out of the ring. And for those of you who don't know what sumo robots is, instead of 2 big guys pushing each other out of a ring, you have 2 robots pushing each other out of a ring. It's an all-black ring with a white line all the way around it. And so generally, if you're autonomous, you'll have look-down sensors here, which then would detect the white line so you're not walking out of the arena yourself. And then look forward sensors or look backward sensors to find the other robot and then push that robot. And then it really becomes a question of torque. That's for the autonomous side. For the remote control side, it is just 2 remote control robots. This year, we're adding a 3rd class due to Google, which is a cloud robotics networking class. So it is a remote control robot like this, but instead of using a standard 2-stick joystick, you use 2 Wi-Fi connections. So basically, you have a wireless controller, be that your laptop or your Droid or whatever, if you want to build your own controller. It goes up to the cloud. The cloud then goes over and comes back down, and correct me if I'm getting this wrong, comes back down to a wireless receiver on your robot. So basically, you cannot talk directly via standard Wi-Fi to the robot. You are talking to a network controller. There's detailed descriptions in the rule set already, so you can read the exact rules as far as how it works. But so you're basically talking to a router, and then that router is talking to another router, which is then talking to your robot and controlling it. And so we're working to make sure that there's almost 0 latency time between that. The question is cloud the same thing as Skynet? Is cloud the same thing as Skynet? And so those are the 2 big money events. And so for those of you, if you already have just a cool robot that you've built, you're already ready to go for Best of Show. If you don't have a sumo robot, you can actually buy 3 kilogram kits from many different web suppliers. And so just basically so you can get over the mechanical engineering hump and throw one together and get it over with, and then start working on the actual programming to talk up and through the cloud. So that's those. Speaking of HBRC, so HBRC will have a dedicated booth, as in previous years. And we're also hoping to have a lot of presenters at that booth. So basically, there will be more show space than there has been in the past in terms of you being able to just show off your robot to the audience, because we sort of realigned how the building is laid out. So it'll be actually easier to do that with where the non-combat stuff happens. It is still in the same building. So it is in the San Mateo Fairgrounds in the Festival Pavilion. Which is very nice. There's private pit area, which we kind of keep control over so that nobody's robots or laptops or whatnot get stolen. There's an in-house restaurant. As far as parking, we do get some freebie parking passes. I will push some of those down to HomeBrew. I don't know, to be honest, how many freebie parking passes we're going to get. It varies by year. One year we got none. Sometimes we'll get like 10. Sometimes they'll throw 50 of them at us. For speaking of presenters, we also have a dedicated presentation room, which is separate from the rest of the building, which will have a raised stage and about 150 seats. So for anybody who wants to do presentations, whether it's a quick and dirty 15-minute presentation on the cool robot that you built, if you're a college student who wants to present a paper that you've been researching, if you're a company that wants to have some time to stand up on stage and hawk your products, that room is available for you. And lastly, volunteers. We always need volunteers. So I'll be actually sending out a couple of emails to the list tonight for volunteers, as well as details on calls for presenters, calls for sponsors, things like that. For those of you who haven't been before, I want to highlight quickly some of the other competitions beyond Sumo and Best of Show. One of them that Homebrew has always been really big on is Robo Magellan, which is actually sponsored by Willow Garage this year. Thank you. And for those of you who don't know what Robo Magellan is, if you know what the DARPA Grand Challenge is, instead of having a full-sized autonomous car go from city A to city B, you have a remote control-sized autonomous car using GPS going through several waypoints. Basically, we take you around the building. And Camp, if later on you want to give a talk about exactly what that details. There's lots of humanoid competitions. I know Bob and Ted, where are you? Bob and Ted are fielding a soccer team this year. So one of the humanoid competitions is 3-on-3 soccer. There's Kung Fu. There's all sorts of other things. Again, 70 different events, including 10 events that are free for kids to enter, no charge for the sub 18-year-olds to enter those 10 events. And I think I mentioned last week, for those of you who don't know, we also have a TV deal with Science Channel. So the Mythbusters will be hosting the event, and Sharp Entertainment, which is a production company, will be filming it for television to be later broadcast on Discovery Network's Science Channel. And that's that. Any questions?
Thank you very much.
You're very welcome.
Okay.
Just one more thing I wanted to mention about National Robots Week, that I guess there's a contest for kids. It's on the Instructables website.
Okay.
So if anybody's interested in entering that, having kids build robots, the Instructables competition.
Okay. Could you mail that one out to the list? Okay, but
They're looking for homeschoolers. We have
okay.
in the homeschool network, we share the information around people in the homeschool network that might be interested as well.
Okay. As you can see, lots of stuff coming on. We haven't even talked about Maker Faire, and I really don't know what's going on with the first competitions, but I think we need to move on, or else we won't have any show and tell today. Can I have a quick show of hands of who wants to show robots tonight? Oh, we've got a huge crowd. We're going to have to be real tight schedule on our robot show and tell tonight, or we'll never finish. So try and keep it fast. If you have setup, come up early and set up while another person is going. Okay? So let's start with our show and tell. I'm going to sort of just sweep across the room. So we're going to start from the right-hand side of the room and go across over to here. So I'm going to start with you. Yes? Come on down. Is there a button?
Zoom or wide.
Okay,
There we go.
okay. What's your name?
I'm Jack Veenstra, and
Okay.
this is my first time here.
Great.
Uh,
Ooh. There it is. Okay. You have to really stick it in
Okay.
straight at.
Can you hear me now? Okay. So I brought my spiky robot, which I modified so I could have a couple servos to control the camera head. I don't know if you've ever seen, anyone ever heard of spiky robots? Okay, a few people. Normally they come with this fancy looking robot body that has arms and the camera head, but everything is in fixed position. And the first thing you want to do is, move the camera head, but you can't with the original spiky robot. But it has Wi-Fi, it has camera, microphone, speakers. You can roll it around in your home, and it was sold as a toy. Unfortunately, it's not easily modified or programmable, but the protocol that it uses to send commands to the spiky robot was reverse engineered and published on the web. So I wrote a Android program for my phone so I can control it over Wi-Fi. I wish I could show you the screen, but let me connect it. So I brought a router with me. It's sitting over there. It gives the spiky robot a fixed address, and then I connect to it with my phone. And the image here is what is being seen by the robot, and then I can move the robot. Can I move any of this stuff, or I'll just okay, I'll just roll this a little bit so you can see. So I can move the robot forward using the trackpad, and as it moves around, I can see what the camera is seeing. So the changes I made. So I wrote the Android program, which is open source. I also made some hardware mods. So let's see. I can change the camera head position. And I can pan side to side if that works. Sometimes it loses the command. Anyway, so the hard part is that this is not easily extended. It doesn't have new commands for controlling servos, and so what other people did and what I copied is you can send commands to blink the LEDs on the spiky robot, and then I soldered wires from the LED and fed them into an Arduino microcontroller, so the Arduino can tell if the LEDs are changing state, and by turning on and off different LEDs, I can send zeros and ones. And then the Arduino sends commands to the servo. So I encode which servo I'm changing and the value and position. But the problem is each bit, I have to send like a 200 millisecond delay between each bit, otherwise I lose packets somewhere. And so that's why there's a delay in the lag. But anyway, it's much better than having a fixed head. You can roll around and you can go look up at people when you get there, and you can look down at the ground when you're moving. So anyway, that's just real quick. Okay.
Thank you very much. Who's next after Tony? It's going to be Ralph? Okay. And who's after Ralph? Dave. Okay.
All right, can everybody hear me? So we got the Kinect here, and this is the first time I've been excited about a Microsoft product in ages. Kinect is what I believe, Kinect and Nito, I believe, are the biggest innovations in robotics in recent history. And the reason is because we get to play with all these fun toys at Willow, and now we can afford to bring them home. And what the Kinect is it's an infrared ranging stereo camera. And for people on the internet who believe this, it's not just a webcam. It's got an infrared projector and two cameras so you can do stereo. It's also got a tilt motor, an accelerometer, and speakers. So it's got a lot of, or not speakers, microphones. But basically all we care about is getting the stereo point clouds out. And I got two methods to do that. One is with ROS. ROS has this really cool thing that extracts the stereo point cloud and actually builds a 3D image of it. So this is the 3D image of the Kinect camera, which is right here. Whoops, hang on. Okay, that's a little better. This right here is the Kinect, and you're seeing a 3D image right now on the screen of the people in front. I should be able to rotate this around. So if you see, I'm rotating the table around. Yeah, there's some lag. Wait. So and I won't do this, but if you zoom in, you can actually see pretty good detail. So you can actually see, like, it's not just like, the people aren't just flat, even though it looks like it in this view. Now, ROS is great for this, and it produces a lot of data. It's also kind of slow. So, in addition, what I've done, hang on a minute here. Okay, I've written my own program here to talk to the Kinect. And the way you do that really easily is with this utility called libfreenect. You can also do it with OpenNI, but libfreenect was very easy to use. And once you install it, it just builds really nice, and you automatically get this. You automatically get a variety of programs, and one of them is this viewer that's up on the screen right now. And that viewer is very nice because it displays depth. It does like a little algorithm to translate the color, so you get colored images. That's on the left, and it displays the camera image. So that viewer is a great tool for hacking to develop your own little Kinect detection program. It's also very fast. It doesn't take up much CPU power. So what you see on the right is I've done some stuff with segmenting out the image on the right. That's the RGB. On the left is the depth, and I've written an algorithm that's I haven't seen before, but it's basically what it does is it takes a look at the derivative of the depth value with respect to the pixels and upwards. So it basically starts at the bottom and scrolls up. And it colors the region that it sees as level as pink. So that's why there's those purple boxes shaking up and down on the top of the pink surface. And so if you put your hand out, you'll see it considers your hand a non-drivable region. And it has a maximum tolerance for tilt, which will be set to whatever the robot can climb up. And so if I go over here and put this book here, you'll see it. Yeah, so there's basically a threshold, and the hope is that by using those purple shaking dots, the robot will be able to avoid obstacles using the Kinect. There you go. I'm not sure off the top of my head, but I'm happy to tell you I'm happy to do that. I'm happy to check that. But it doesn't, I mean, it's not like a huge CPU load, but it's gonna be annoying. I mean, you know.
Depends on how powerful. Do you need your display?
No.
I might not have nothing. If I can't get this to work, nothing's going on.
I'll get out of here now.
We can have Dave go.
Well, I found one option that may enable it for me.
Why don't you come up, Dave, and if he has technical difficulties, we'll swap orders. I'm going to call you technical difficulties.
Okay, that's fine.
Dave. So.
I found the driver had to turn on the external display.
Okay, who's after Dave over here? Alan, Camp, Ted, you, I don't know your name yet. Yes, Bob. Alan, right? Oh, two Alan, sorry. Alan, Camp. Okay. Why don't you come over here and one of you grab the mic.
It'll be fine. Okay. What? Oh, okay. Hang on. We'll get the robot up here, and then why don't you just turn him loose there? Okay. Then you take the microphone and talk about what's going on. I'll grab the cable.
So we got an XV11, and we got a Python program that runs a subsumption architecture, control architecture. And subsumption architecture is you have behaviors, and they decide when to run. They have a select method, and they have a start method, and the resume method, and a suppress method. And the select method tells you when they want to run. The start method tells you how to start running them. Resume tells you how to resume running them, and suppress tells you how exactly to stop them. And we have 5 behaviors, not counting the default do nothing behavior. That's always at the lowest priority. The highest priority behavior is stop on pickup, where if it just gets into a tight corner, you can just pick it up and it stops, which is really handy. And then the next highest priority is magnetovore, and you may have noticed I'm carrying a magnet on a stick. And you probably did notice, in fact, but so there are magnetic sensors under the bump sensor, and it follows the magnet if you stick it underneath. This carpet does not work that well with it, but on hardwood floor it works, because that's what's in our house. And then there's LiDAR bump. It uses the LiDAR sensor. It divides it into 8 segments, and if either of the two, I can't reach it with my foot. If either of the 2 in the front has something in front of it, it'll back and turn. And we have something like that going with the bump sensor too, but it's really kind of stupid. It always turns in the same direction. And it can get caught in traps really easily. But oh, great.
Okay, keep going.
And then the lowest priority behavior is forward, where it just trundles along until some other behavior wants to run.
We just sewed it up with the mag. You know what? Demonstrate the stop on pickup.
Uh,
You gotta untangle the cord.
All right. Here, hold this.
Okay. Okay, yeah, that uses the wheel sensor. So anyway, the reason I'm carrying this laptop around is we had the software running on her workstation, and the idea was to transfer it to a Chumby. If you know, in show and tell, you might want to look at this. We've got a little Chumby sitting in what would be the dirt bin if we were still using this as a vacuum. And right there's the Chumby has an issue with the USB driver in it that I'm chasing down, so it doesn't really get along with it. So we didn't make it all the way to the Chumby, but we did at least compress it to a laptop. And later on, afterwards, we can run it off the Chumby a little bit, and you'll see how it behaves that way. So anyway, did I have anything else to say about this? I guess not. That's probably it. So.
You ready, Ralph? Okay. I think we're still snarled.
Well, just unplug the USB. Okay. A little bit awkward because to show what I want to show, I can't see half the screen myself, but I think this will work.
Okay.
All right, just gonna move this out.
Okay. So another Kinect, and I like Tony think the Kinect is one of the coolest things that's happened this year.
People were more excited about the Kinect for robots than for gaming.
Right here. Okay.
All right. So yeah, this is another Kinect project. I put it on a robot, and it's running ROS here. So I won't go into details of the Kinect. However, I did design mine so that one screw and it comes off and still plugs into the Xbox, so I can still use it for gaming as well. So anyway, again, this is ROS. And if it's going to talk to me, the XB is working. It's got a flaky connector on there for the XB. Okay. Right now it's running, as I said, from it with an XB interface here just to talk to it, and the Kinect is tethered via a USB cable. I have the Panda board on order to try to make the whole robot autonomous. is it's a connector. It could just be the wireless interference in here. The XBs are really hopeless. But anyway, if I do anything, there we go. Now it's driving. So what I've done with Ross here, it's getting telemetry, and like Tony, the yellow field that you see is processed from the actual connect point cloud, where I've just taken a wall in front of what's the closest thing that could bump into the robot, and then I'm using that to generate an occupancy grid map, which is kind of where the black dots. There's not a lot of detail on the room there, so you're just seeing a bunch of sort of scattered. And probably the carpet is getting noise, calibrating exactly where the ground is and filtering that out from your wall. I think it's picking up a lot of noise from the carpet here at the moment. And that's one thing, just calibrating the tilt angle is a problem that affects where your ground is going to be. So having moved the thing, it's probably now a little bit out of whack, and why I'm seeing not such a good image. But I was moving that around. I have hardwood floors at home, and it completely misses the floor and gets all the obstacles. But anyway, this is, with some more calibration, you can see where we're going. And this is Ross. Once we get the occupancy grid mapping working, you can feed that into a SLAM algorithm and do the SLAM mapping and things with it. So I won't take up any more time.
Okay. Thank you. I think that's pretty good. Two Ross demos given that the talk was given last month. So, so Alan.
This is a variation on the Club Bot. There's no popsicle sticks, and I'm still a bit leery. This is the first day that it's ran on top of a table, so I'm like a proud parent. All right, get out of it. Okay, here we go. There's two sets of sonar IR detectors, forward and yellow set that it was exercising looking at the table. See what it'll do here. And I think the next step is to, instead of avoiding it with the forward-looking IR, I'm going to make it find something like come on, be nice, like a block to push, and that'll be phase 2, I guess. So it does seem to be working. So I'd rather not fall off with it. This has got a few more parts on it. There's a little shield, prototype shield on it. I mentioned the IR sensors in the front, the batteries on the bottom, and I've used metal brackets for most of it instead of the popsicle sticks. There's a plexiglass disc that is the rest of the body.
And for those of you who don't know, we kicked off a club starter robot project. Are you going to talk about that, Camp? Okay, so Camp will be talking about that. But before Camp, Alan Fetterman will be coming up next. And I'd like to thank everybody so far. We've been keeping the pace up. We're a little behind schedule, but we're not too badly behind. What?
Okay. Thank you. One of the things I'm working on is this general purpose household robot gopher. And the idea is to have one robot that'll do everything. So right now my robot vacuums, mops, and flips burgers. So I figure those are essential because pushing a broom and flipping burgers is the only thing I'm fit for nowadays, apparently. But the next thing I want to do is, besides vacuum and mopping, if there is a sneaker in front of the vacuum, pick it up. So the thing is, how do we design a robot arm? So like, not to beat on the people at Willow Garage, they have a robot that has an arm that weighs like 100 pounds and can lift 4 pounds. I want an arm that weighs 4 pounds and can lift 4 pounds. So I want to do that out of commonly available materials, cots. I believe in cots. So I think the best thing to do is box beams, and I'll demonstrate this in a minute. But I also figured out that if you just get a couple of aluminum cans, fill them with foam, they would be strong enough to do it and weigh around 5 ounces. And you wouldn't even have to carbon reinforce it. So now I'll try to demonstrate that and fall flat on my face. This is around the 5-pound. That's Gorilla Tape. But if the cans are empty, they're starting to fail up. But if I filled it with foam, it would, I think it would work. So that's around 4 ounces. No, it's around 1 ounce, holding 5 pounds. So then, the idea is we use the powerful motor to do the powerful torque. So right now I'm doing this with one finger, right? So I'm not using a lot of torque to pull that up. Just using a mechanical advantage to lift that up. So I'd use a automotive motor. Actually, the wire is starting to slip, but that's working. So I use a very low-powered motor to do that translation because that's on a nice bearing, and something like an automotive seat positioning motor. This little motor is good for moving someone who weighs around 600 pounds back and forth. Uses double worm gear reduction. It's slow, but it's very powerful. Only weighs a couple of ounces and can move several hundred pounds. So that's my story, and I'm sticking to it.
Okay. You want to come on up, Kemp? And then next will be Bob. You're Bob, right? Okay. Rob or Bob? Rob. Rob, Ted, and then the gentleman behind Ted. Is there anybody else in the show and tell queue? No. Okay. So we're doing pretty well.
Everybody knows Bones, maybe not. Anyway, it's my Halloween stuff. My buddy's in a rock band called Black Mass. I performed with him last Saturday night at the Quarter Note in Sunnyvale. And we had a lot of fun. This is Caw the Crow. He was up on stage, flapping his wings. Turning his head. Oh, thank you. Yeah, and this, of course, is Bones, as I mentioned. There we go. And so, it was a lot of fun. I'm actually the band roboticist now. And so, you'd have the crow flapping his wings up and down on the stage, turning his head, to the beat and so forth. And then every now and then Scully would take a cruise across the dance floor. Pretty funny. Robot-human interaction, people generally just stand around, but when the dancing skeleton comes through, they actually start dancing with it, so it's a lot of fun. So this is Caw. Oh, I almost forgot one part. Hang on a second. Yeah, hang in.
Pause for.
And for those of you that don't consider these to be real robots, get life. I've lost my cough crow, but he's got a crow he's got like a bird collar that I'm going to integrate in him and have ultrasonics. And this will be a lot of fun, I think, for Maker Faire and Robo Games. You walk up to him and all of a sudden this thing's jumping out at you. So that's Bone Scully and Caw the Crow. Thank you very much.
Thank you very much. Okay.
Hang on, I got one more.
Oh, sorry.
This is the Club Bot. This is like official business. We're having a lot of fun the penultimate Wednesday of every month at the Tech Shop. Thank you, David Curtis. We're building a standard base. We've actually agreed on some things, including processor, type of actuator, and wheel, and goal. The goal being we're going to build table bots, and we're going to be able to have them be micro mice also. In Servo magazine, there's articles published by Gordon McCoon, author of the Robot Builder's Source Book, and we've gotten permission to reprint the articles that he's writing in Servo on the Ardbot, which is perfect. It's like, this is an Arduino, this is a football, this is an Arduino, and you go from there. Actually, in the last meeting, Carlos brought an Arduino and servos and wheels parts and left the meeting with a functioning robot. So that's what kind of fun we're having. And we're going to start having like 2 pers in April, where it's just like Arduino Uno, continuous rotation servos, the wheels. We've got acrylic circles and stuff like that. Some of us use duct tape and Velcro and double stick tape and U-glue and stuff. Others of us of the more engineering bent, Alan, have the precise standoffs and cut metal chassis. But homebrewed robots have personality, if nothing else. So that's what it's all about. We're having a lot of fun at the tech shop. The last Wednesday every month. Show up. It's the builders meeting. This is one of the HBRC bugs. I call him Buggy. And see, I'm not going to be all hedging around him and stuff. Let's see if he can do a phase 1 here. Well, there's a 4th phase now. It's a transcendent phase. In other words, it's okay to fall off the table as long as it still functions when you put it back on. That's a joke, folks. You can laugh. Okay, so here's a block. He's got whisker switches. He's bumping into the block, but I think he's going to make it to the other end. So exciting. Yes, that's a phase 1. All right, thank you very much.
Okay. Rob, could you come up here? I just, as president, I was always being asked how to get started, and I said, well, I don't know. So we kicked off this Club Robot project. So now when people ask the question, where do I get started? I just say, come on, show up at the tech shop on the appropriate day, and in a meeting or two, you'll have a nice starter robot. So here you are, Rob.
We've got a sub-mailing list besides the general mailing list, and if anybody would like to be on that mailing list, shoot me a line directly.
Okay. You'll have to send a general message first, though. Let's let people know about it, okay? That's the rule.
Hello, my name is Rob Harrell. I have 2 robots here, although actually probably they're more like 1.5. Unfortunately, one just had a structure failure as I was taking it out of the box, but fortunately that's not the one that moves right now. So it's 1.5 robots because maybe you saw this last month. I have my robot here with the Nito wheels.